semiconductor engineering, why the chiplets are so critical in automotive. Auto and security pervasive computing. Achieve the chiplet interoperability is a competitive necessity, but it requires clearly number of technical hurdles. Chiplets are gaining renewed attention in automotive market where increasing electrification and intense competition is forcing companies to accelerate their design and production schedules. Electrification has lit a fire under some of the biggest and best-known car makers, which are struggling to remain competitive in the face of the very short market windows and constantly changing the requirements. Unlike in the past, when the car makers typically land on a 5 to 7 years in design cycles, the latest technology in vehicle today will be considered dated within several years. And if they cannot keep up, there is a whole new crop of startups produce the chip makers with the ability to update or change out the features as quickly as a software update. The software has speed, security, reliability, and limitation, and being able to customize the hardware as well. Many automakers are now putting their effort. This is where chiplets fit in, and the focus now is on how to build enough interoperability across a large ecosystem to make this plug and play market. The key factors to enable automotive chiplet interoperability include the standardization and interconnect technologies and communication protocols, and power and thermal management, security testing, and ecosystem collaboration. Similar to non-automotive application at the board level, many design efforts are focusing on a die-to-die approach, which will drive a number of novel design considerations and trade-offs. At the chip level, the interconnect between the various processor, chip, and memory and I/O are becoming more complex to the increased design performance requirements, spurring a flurry of the standard activities. Different interconnect interface types have been proposed to serve varying purposes, while emerging chiplet technology for dedicated function, processor and memories and I/Os, to name a few, are changing the approach to design. There is a realization by automotive OEMs to control their destiny, and they're going to have to control their own SoCs, said David Phillips, Vice President of the Virtual and Hybrid System at Siemens EDA. However, they don't understand how far along EDA has come since they were in college in 1982. Also, they believe they need to go the latest process node. Well, the mask is set going to cost $1 million. They cannot afford that. They also don't have access to the talent because the talent pool is very small. With all that together comes from a realization by the OEMs that to control their destiny, and they need the technology that's developed by others, but which can be combined however needed to have a unique differentiated product. They are confident and future proof for at least a few model years. Then it becomes economically viable. The only thing that fits the bill is chiplets. Chiplets can be optimized for specific functions which can help automakers meet reliability and safety and security requirements, and with the technology that has been proven across the multiple vehicle designs. In addition, they can shorten time to market and ultimately reduce the cost of the different features and functions. Demand for chips has been on the rise of the past decade. According to the Allied Market Research, global automotive chip demand grew from 49.8 billion dollars in 2021 to the $121.3 billion by 2031. The growth will attract even more automotive chip innovation and investment, and chiplets are expected to be a big beneficiary. But the marketplace for chiplet will take time to mature and it will likely roll out in phases. Initially, a vendor will provide different flavors of the proprietary dies. Then the partners will together to supply a chiplet to support each other. As has already happened with some vendors, the final stage will be universally interoperable chiplets as supported by UCIe or some other interconnect scheme. Getting to the final stage will be the hardest and will require significant changes to ensure the interoperability. Large enough portions of the automotive ecosystem and supply chain must come together, including hardware and software developers, foundries and offset, and material and equipment suppliers. The momentum is building. On the plus side, not all of these starting from scratch. At the board of level, modules and subsystems already have used on-board chip-to-chip interfaces, and they will continue to do so. Various chip and IP providers, including the Cadence, Diano, the microchip, and NXP and Renesas, Lambus, Infineon, ARM, and Synopsys provide off-the-shelf interface chips or IP to create the interface silicon. The Universal Chiplet Interconnect Express UCIe is consortium as the driving force behind the die-to-die open interconnect standard. The group released its latest UCIe 1.1 specification in August 2023, and board members including Alibaba, AMD, and ARM and ASE as Google Cloud and Intel, Meta, and Microsoft, Nvidia, Qualcomm, Samsung, and others. Industry partners are showing their widespread support. AIB and a bunch of wires BWRs has been proposed. In addition, ARM just released its own chiplet system architecture, along with an updated ARM perspective standardized protocols for chiplet. The chiplets are already here, driven by Nexus D, said Arif Khan, Senior Product Marketing Group Director for Design IP at Cadence. The growing processor and SoC sizes are hitting the electrical limit. These economies of scale, incremental gains from process technology advances are lower than the rising cost per transistor and design. The advances in packaging technology 2.5D or 3D and the interface standardization at a die-to-die level, such as UCIe, will facilitate the chiplet development. Nearly all of the chiplets used today are developed in-house by big chip makers such as Intel, AMD, and Marvell because they can tightly control the characteristics and the behavior of those chiplets. But there is work underway at every level to open this market to more players. Once that happens, smaller companies can begin capitalizing on what the high-profile trailblazers have accomplished so far and innovating around those developments. Many of us believe the dream of having off-the-shelf interoperable chiplet portfolio will likely take a year before becoming a reality, as said the Guillaume Boyle, Senior Director of Strategy Marketing at iTrace, adding the interoperability will emerge from groups or partners who are addressing the risk of the incomplete specifications. This also is raising the attractiveness of the FPGA and the eFPGAs, which can be provide a level of customization and updates for the hardware in the field. Chiplets are real things, said Joe Tate, the CEO of FlexLogix. Right now, a company building a 2 or more chiplets can operate much more economically than a company building Lear reticle size die with almost no yield. The chiplet standard standardization still appears to be far away. Even you say it's not a fixed standard yet. Not all agree on UCIe, where data testing, and who owns the problem when the integrated package doesn't work, etc. We do have some customers who use or are evaluating the eFPGA for interfaces where the standards are in flux like UCIe. They can implement the silicon now and use the eFPGA to conform the standards changes later. There are other efforts supporting chiplet as well, although for somewhat different reasons. Notably, the large cost of device scaling and the need to incorporate more features into chips, which are electrical constraint and most advanced nodes, but those efforts and pave the way for chiplet in automotive, and there is a strong industry backing to make there is a strong industry backing to make this all work. For example, under the sponsorship of the SME and the IEEE societies, the new heterogeneous integration roadmap (HIR) looks at various microelectronics design, materials, packaging issues to come up with a roadmap for the semiconductor industry. Their current focus including the 2.5D and 3D ICs, wafer level packaging, integrated photonic and MES and sensors, and the system in package SIP, and aerospace and automotive and more. At the recent Heterogeneous Integration Global Summit 2023, a representative from the AMD and Applied Materials, ASC, and RAM Research, and MediaTek, Micron, and Onto Innovation, and TSMC, and others demonstrated strong support for chiplets. Another global forum that supports chiplets in a chiplet design exchange CDX working group, which is part of the Open Domain Specific Architecture ODSA, and an Open Computer Project Foundation (OCP), and the Chiplet Design Exchange (CDX) charter focuses on the various characteristics of the chiplet and chiplet integration, and including electrical and mechanical and thermal design exchange standard of 2.5D stacked and 3D integrated circuit (3D ICs). Each representative, including ANSYS, Applied Materials, ARM, the AR Labs, and Broadcom, and Cadence, Intel, the MACOM, and Marvels, and some Microsemi, and NXP, and Instruments EDA, Synopsys, and others. The things that automotive companies want in terms of what each chiplet does in terms of functionality is still in an uphill mode. James Fritsch noted. One extreme has these problems. The other extreme has those problems. That is the point. This is what's needed. And these types of companies can go off and do that sort of work. And they could put them together. Then this interoperability thing is not a big deal. The OEM can make it complex by saying, I have to handle that whole spectrum of possibilities. The alternative is that they could say, it's just like a high-speed PCIe. If I wanted to communicate from the one to the other, I already know how to do that. I've got a driver that are running my operating system that would solve an awful lot of problems, and that's where I believe it's going to end up. The one path to the universal chiplet development. Moving forward, chiplets are a focal point for both the automotive and the chip industries. That will be involved everything from the chiplet IP to memory interconnection and customization options and limitations. For example, NESA's Electronics announced in November 2023 plans for each generation SoC and the MCUs. The company is targeting all major applications across the automotive digital domain, including advanced information about its fifth generation R car SoC for a high-performance application with advanced in-package chiplet integration technology, which is meant to provide automotive engineers greater flexibility to customize their design. Renesas noted if more AI performance is required to advance the driver assist system ADAS, engineers will have the capability to integrate the AI accelerator into a single chip. The company said that this roadmap comes after years of collaboration and discussion with the Tier 1 and OEM customers, which have been clamoring for a way to accelerate development without compromising quality, including design and verifying the software even before the hardware is available. That due to the ever increasing needs to increase compute on demand and the increasing need for higher levels of autonomy in the cars of tomorrow, we see challenges in monolithic solution scaling and providing the performance needs of the market in upcoming years, said Vathans Warren, Senior Director for SoC Business and Strategies at Renesas. The chiplets allowed for the computer solution to scale above and beyond the needs of the market. Renesas announced plans to upgrade the chiplet-based product family, specifically targeted at the automotive market starting in 2025. The standard interface allows for SoC customization. It is not entirely clear how much overlap there will be between standard processors, which is where the most chiplets are used today, and the chiplets developed for automotive applications, but the underlying technologies and the development certainly will build off of each other as this technology shifts into new market. Whether it is an IR accelerator or a ADAS automotive application, customers and need standard interface IP blocks, noted David Ridgway, Senior Product Manager, and IP Accelerator Solution Group, and Synopsys. It is important to fully verify the IP subsystems around their IP customization requirement to support the subsystem component used in customers' SoC. When customization, you might not realize how customizable IP has become over the course of the last 10 to 20 years, and the PHY side as well as the control side. For example, PCI Express has gone from PCIe Gen 3 to Gen 4 to Gen 5 and now Gen 6. The controller can be configured to support multiple bit bifurcation modes of the smaller link width, including the 1, 16 times, 2, 8 times, or 4 times. Our subsystem IP team works with the customers to ensure all the customization requirements are met. For I/O applications, signal and power integrity is extremely important to meet their performance requirements. Almost all our customers are seeking to push the envelope to achieve the highest memory bandwidth speed possible so that their TPU can process many more transactions per second. Whenever the application, the cloud and computing or artificial intelligence, customers want to fastest response rate possible. The figure 1 is IP blocks including processors, digital IP, and verification help developers to implement the entire SoC. The cost optimization PPA serves the ultimate goal of the increasing efficiency, and this makes chiplets particularly attractive in automotive applications. When UCI matures, it is expected to improve overall performance exponentially. For example, UCI can deliver a shoreline bandwidth is a 28 and 24 gigabyte per sec per millimeter in a standard package, and 165 to uh, 1317 gigabyte per sec per millimeter in an advanced package. This represents a performance improvement of the 22 to 100-fold, bringing latency down from 20 nanosecond to 2 nanosecond, represent a 10-fold improvement. Around 10 times greater power efficiency at 0.5 pJ per bit, picojoule per bit, standard package, and 0.025 the pj per bit advanced package is another plus. The key is shortening the interface distance whenever possible. To optimize chiplet design, the UCI consortium provides some suggestion. Careful planning, consideration of architectural color lines, that is, the chiplet, i.e., that is chiplet boundaries, optimizing for power, latency, silicon area, and IP reuse. For example, the customizing one chiplet that needs a leading edge processor node while using other chiplets on older nodes may impact cost and time. Thermal and mechanical packaging constraints need to be planned out for package thermal envelopes, hotspots, chiplet placement, and I/O routing and breakouts. Processor nodes need to be carefully selected, particularly in the context of associated power delivery scheme. That's a strategy for chiplet, and package assembled parts need to be developed up front to ensure the silicon issues are caught at the chiplet level testing phase rather than after they are assembled into a package. The conclusion: the idea of a standardizing die-to-die interface is catching on quickly, but the path to get there will take time, effort, a lot of collaboration among companies that rarely talk with each other. Building a vehicle takes a determined car maker. Building a vehicle with a chiplet requires an entire ecosystem that includes developers, boundaries, and offsets, and material and equipment suppliers to work together. Automotive OEMs are experts at putting systems together and at finding innovative ways to cut costs, but it remains to be seen how quickly and effectively they can build and leverage an ecosystem of interoperable chiplet to sharing design cycles, improve the customization, and adapt to a world in which the leading edge technology may be outdated by the time is also fully designed and tested and available to consumers. Okay, thank you for your time. I read this article, why chiplets are so critical in automotive. Thank you again. See you next time.